In this video we have some exponential equations to solve, and this is basic algebra because we're not going to be using logarithms. A lot of times you have to take the log of both sides to a certain base, say base 10 or base e, in order to solve it. But for this video we're going to use this property that tells me if I have a base b, and the only condition here is we want the base b to be positive and the base cannot be 1. If I take this base to an x power and then I take the same base to say a y power, the only way that b to the x will equal to b to the y if the base b is positive and not equal to 1 is x has to be y. So under these conditions here, positive base not equal to 1, if b to the x is equal to b to the y, then the only way that that can happen is if x is equal to y. It has to be the same exponent. So in other words, if I give you, say, 2 to the third is equal to 2 to the x, well, 2 to the third is 8. So the only way that that could equal to 2 to the x is if x is the same thing as 3. Okay, so with that in mind, let's look at the first equation. We have 3 to a power of x to the third equal to 9 to the x. So here what we're going to be doing is looking to see if we can get the base the same to look like this. So this one is 3, got an exponent of x to the third. I know I can write the 9 as 3 squared and then still take that to the x power. Power to a power, you multiply exponents, so this would be the same thing then as 3 to the 2x. Now I've got the same base here. Got 3 to the x cubed is equal to 3 to 2x. This implies that x to the third, or x cubed, has to equal to 2x. That generates an equation which you can solve. In this case, we simply bring the 2x over to the left side, make it a minus 2x, changes the sign, and then we can factor out an x here. So give me x, that'll leave me with an x squared minus 2 equal to 0. Well, the only way that a product can be 0 is if one or both of the factors are 0. So that means we can set x equal to 0 and set x squared minus 2 equal to 0 and solve. Well, this one's already solved, x equal to 0. So for this one, I should say that's x squared. So take that over, that's a 2. Take the square root of both sides, plus or minus. Taking the square root of x squared gives me x, and the square root of 2 could be plus or minus square root of 2. And that's your solution. X can be 0, or it could be the square root of 2 or minus the square root of 2. I just put it as plus or minus square root of 2. And that's the solution to that one. Now for number 2, we have 5, and the power on that is x squared plus 8. And then we have 125 taken to the 2x power. 125, though, can be written as 5 to the third, and that's to the 2x power. So you got a 5 here as a base and a 5 over here. So now using laws of exponents, we can rewrite that by applying one of the laws of exponents. Power to a power, you multiply the exponents. So this would be 5. 3 times 2x is 6x. So now we have base of 5 here, base of 5 here, and there we have equality here. So that means the exponents have to be equal. So that means I can say that x squared, the exponent on the left side, should equal to the exponent on the right side, because the bases are the same. So I get a quadratic this time. X squared plus 8 is equal to 6x. So let me bring the 6x over, be x squared, take that over, minus 6x plus 8 equal to 0. The quadratic, one side is 0, so we can factor this into x minus 4 and x minus 2. Set each factor equal to 0 and solve for x. So if I set this one equal to 0, bring the 4 over, I get x equal to 4. If I set this one equal to 0, x minus 2 equal to 0, take the minus 2 over, I get x equal to 2. So my two solutions for this quadratic then, x can be 4 or 2. You can always go back and plug into the original equation to check and realize that it does give you the same number on both sides of the equation. But that's the solution for number 2. Now for number 3, again, exponential e to the 4 taken to the x power. So let's just multiply exponents. Okay, lots of exponents, I can multiply those powers. So this will be e to the 4x, e to the x squared, and that's equal e to the 12th. Now let's rewrite this. I have the same base here. Again, lots of exponents, I can add the exponents. So this will give me e, it'll be e, the power will be x squared plus 4x. And that'll equal to e to the 12th. Now I have the same base on both sides here. So the only way I can have equality here is if these exponents are the same or equal. So x squared plus 4x has to equal to 12. On the first one we had a cubic equation, solved it by factoring. This is quadratic again. So let's rewrite it as x squared plus 4x. And bring the 12 over, make it a minus 12 equal to 0. And we go ahead and factor this. It's the factor into x plus 6 and x minus 2. That's equal to 0. And then we set each factor equal to 0 and solve each linear equation there. So x plus 6 equal to 0 means x has to be negative 6. X minus 2 equal to 0 means that x has to be 2. So my two solutions are x equal to negative 6 and 2. And that's your solution for that one. Thanks for watching. We'll see you next time.